This video is the start of a series of videos about how to get derivatives. We've done differentiation by first principles. Now we're looking at how to get derivatives in a much easier and quicker fashion. You'd have seen this last year. If f of x equals ax to the power of n, then f dash x equals n times a times x to the power of n minus 1. In other words, to get the derivative, you take the index there, put it at the front of the expression, and then reduce the index by 1. That's how I usually explain it. Put the index out the front and reduce the index by 1. The other thing to note here that if your function is just a plain number, a constant, then the derivative is 0. The derivative is 0. So the derivative of a constant, for example, the derivative of y equals 7 to y dx, the derivative of it would be 0. Alrighty, so here's some simple ones. If y equals x to the power of 7, there it is there. How do we do it? Okay, so we put the 7 out the front there, and we get 7 there, and then we reduce the index from 7 back to 6. So we end up getting 7x to the power of 6. Let's rub those out again. So 7 goes out the front, reduce the index by 1, 7x to the power of 6. Same with the next one. The 4 goes out the front, gets multiplied by the 5, you get 20. And then you reduce the index by 1, we get 20x to the power of 3 as the derivative. Alright, if we've got a combination of things, then we take each term in the expression separately. So dy dx equals 4x to the power of 3. 4 goes out the front, reduce the index by 1, minus 2 times 3 on 2 is 6 on 2. 6 on 2 is 3. X to the power of, reduce the index by 1, becomes x to the power of 1 or just x. And of course the derivative of a constant is 0. So our derivative is simply this, 4x cubed minus 3x. What about if we've got brackets? Well, the first step here we've got to do before we get the derivative is remove the brackets first. So f of x equals x squared minus 3x plus 2x. That's going to be minus x minus 6, because positive 2 times negative 3 is negative 6. Therefore, when we get the derivative, f dash x equals 2x minus, what's the derivative of negative x? Okay, the derivative of anything x, the derivative of 7x is 7. Derivative of 5x is 5. The derivative of negative 3x is negative 3. So the derivative of negative x, or negative 1x, here is negative 1. And the derivative of a constant, negative 6, is 0. So we've got our derivative there, it's just 2x minus 1. So the method there is to remove brackets first and then get the derivative. Okay, on to some harder ones now. Let's start with 1 over x plus 1 over the square root of x. So before we go any further, we have to fix this up and remove it from fraction form into index form. 1 over x is the same as 1 over x to the power of 1. And if we get that out of fraction form, x to the positive 1 goes to the numerator position, becomes x to the power of negative 1. Okay, let's have a look at this one here, 1 over the square root of x. Now that is the same as 1 over x to the power of 1 on 2, which is the same as x to the power of negative a half. Okay, x to the power of negative a half, make sure the negative's there. Okay, so we're going to change that to x to the power of negative a half. So before I can differentiate, I must convert things to index form out of fraction form. Alright, f dash x. Remember our little rule here, the index goes out the front, so we get negative 1 x, and we reduce the index by 1. If I reduce negative 1 by another 1, I get negative 2. Okay, so it's negative 1 x to the power of negative 2. Now, you don't really need the negative 1 there. So we'll just make that negative x to the power of negative 2. All right, next one. We take the index out the front. It becomes negative a half x to the power of. Now, if we reduce negative a half by 1, so negative a half take 1, negative a half minus 2 on 2 equals negative 3 on 2. So that's one we use quite a lot. So if you're reducing negative a half by 1, it becomes negative 3 on 2. Let's copy that over to the next slide. Okay, we'll continue on. Got the question there in the left-hand corner. Now we're nearly finished. We have to tidy up both expressions here. It's always good to express them as positive indices. So negative x to the power of negative 2 is the same as negative 1 over, if I take the x to the power of negative 2 to the denominator position, it becomes x squared. The other one, negative 1 x, sorry, not negative 1x, beg your pardon, negative 1 over, the 2's underneath, and then we take the x to the bottom, and instead of being negative 3 on 2, it becomes x to the power of 3 on 2. Last step, this one stays the same. You might remember from our work on indices that to the power of 3 on 2, see that there, to the power of 3 on 2, okay, it can also be written as the square root of x cubed. Same thing. Okay, so there's our answer. I'll put a rectangle around it so you can see it fairly clearly. That's the answer to our question there. Next one, differentiate x plus the square root of x over x squared. A few steps involved here. Now, one thing I want to point out, just digress for a moment, might even do it in orange here so we can see it. Remember that a plus b over c is the same as a over c plus b over c. We can deconstruct that term to that. Now, we use that quite a lot and you need to recognise it. Okay, so what we have to do here, if we're differentiating this, okay, so dy dx, let's say it was y equals, I didn't actually put that down. Okay, to find that, we're going to have to, sorry, before we do that, we're going to actually split this fraction up into two pieces. So it's going to be x over x squared plus the square root of x on x squared. So you can see there, by doing that sort of process, deconstructing, we can go with that. Now, of course, it doesn't work in the other way, so please don't never think that a over b plus c equals a on b plus a on c. That's not the case. Okay, so erase that from your mind. But it does work when you've got that situation with two things in the numerator, the same denominator underneath. You can split it up like I have. Alright, now we have to fix it up. So x by itself is x to the power of 1. So x to the power of 1 divided by x squared is x to the power of negative 1. Go to that straight away. And here, okay, if we just look at this one here, that's x to the power of a half over x squared. Subtract indices. A half minus 2, okay, is x to the power of negative 3 on 2. Right, have a good look at that. I've split up the fraction and I've done the division, and they're both in index form. Now we can find the derivative. So dy dx equals negative 1 goes out the front, x, reduce the index by 1, plus, in fact it won't be plus, index comes out the front, minus 3 on 2, x, reduce the index by 1, minus 3 on 2 minus 1 is the same as minus 3 on 2 minus 2 on 2 equals x to the power of negative 5 on 2. Alright, we'll copy that one over to the next slide. There's a little bit more to do just yet. Right, keep going now and express with positive indices. this will be negative 1. We're taking the x term because it's negative to the denominator position. So it's negative 1 over x squared minus 3. Once again, trying to make the indices positive. That means we take the x to the power of negative 5 on 2. Oops. And we take it to the bottom. So what I've done there is made the two indices, there and there, positive by taking them to the bottom, taking them to the denominator. Alright, so last bit equals negative 1 on x squared minus 3. Now is this step totally necessary? Probably not, but power of 5 on 2 is the same as, just leave the 2 there, the square root of x to the power of 5. Okay, I contest that you'd still get full marks for getting to there, but anyway, that's that last conversion as well. Last question, we've got a derivative to find, and also we've got to substitute into that derivative once we have found it. So let's have a look. First of all, to find f dash x, go back to my black pen, fairly straightforward, except what we might do here first of all, we might take this expression here and make sure it's expressed in index form. Okay, so there's our expression. Now, to write it in, index form, we write it out of fraction form to index form, I meant. So what we need to do is fix up this last one here. It's 8 over x, which is 8 over x to the power of 1. That's 8x to the power of negative 1. Then we can find f dash x once we've done that. Equals 3 to the front reduced by 1, 3x squared. 2 to the front multiplied by the 2 gives 4, reduce the index by 1. X to the power of 1 is just x. Index to the front, so that's 8 x to the power of negative 2. Okay, so there's our derivative. Now, that could go one step further if we just cross this over to the next slide. In that we could put equals 3x squared minus 4x plus 8 over x squared. Remember, we always try and make these negative indices positive by changing them to the other side of the fraction line. Now, we're asked to find f dash 2. Find that, simply a matter of substituting 2 into the derivative. And here we go. Substituting 2 into the derivative. So that's going to be 2 squared is 4, 3 fours are 12, minus 8 plus 8 over 4 is 2. So that's 14 minus 8. That's right. That's correct. So that's going to be 14 minus 8 is 6. Just realised I made an error back here. When I multiplied the 1 by the negative 8 before, I should have had a negative here. Hope you picked that up. So let's have a look at that. That should have been a negative there. Why? Because when I multiply the index by the number out the front, the coefficient, I get negative 1 times 8 is negative 8. Okay, so I've then got to make sure all these other ones are negatives. That's why I hesitated before, because I thought, I don't think I've got the right answer here. And that makes that negative 2. There, and therefore the answer was in fact 2. Okay, this would enable you now to do exercise 7C on page 331. And fairly soon I'll show you how to do more complex ones using the chain rule. That's all for now.